So I'll just make a little disclaimer before I do start the presentation, and that's all the observations and all the readings and everything in this presentation are my own readings and my own personal beliefs. I'm not saying these are the facts. I'm just saying from my observations I've come to these conclusions. So that's what got me thinking about the circle model, that if you was on a circle model, wouldn't the moon speed up to cover the more ground? That was my thinking at the time, but I've moved completely away from models now. All I'm going to say is the Earth's flat because there's no measurable curvature over large bodies of water, not because it's a pizza or a Pac-Man or whatever you want it to be. So as you can see, them readings, there was all from my location, Ripley, UK, meridian passing for March 2017. When I first posted my original moon race video, someone says, yeah, but when the moon's further away, it will appear to move slower because of parallax, you know. So when a celestial object is further away and it will appear smaller, it will take longer to actually cross your screen. So he says that's what would happen in reality. So what I did, I took readings from the equator. I basically went on to time and date, exact same month, but I took the readings from the equator. And what you find is you get the exact same results. Even from their perspective, if you did the experiment from the equator, you'd get the same results. There you see on March 6th, 7th, the moon took 24 hours, 57 minutes to occupy the same spot. On the 12th, it speeded up, took 24 hours, 46 minutes. Remember, they're ahead of us, so it would have been actual there on their time, because there's quite a lot of time difference between the equator, especially in Pontianak, Indonesia. And then again, on March 21st, 24 hours, 49 minutes. So that's from 2 locations, but I went even one step further then. I took readings from a place in Ushuaia, which is on the southern tip of Argentina, which is on the exact opposite southern latitude to the UK. And guess what? You get the exact same results again. So it doesn't matter where you are on the plane, the moon should always speed up from that perspective. So that's quite interesting in itself, because that surprised me, that I expected some slight variation in numbers, but they're exactly the same. Everywhere you go, that moon will appear to speed up from their perspective. It doesn't matter where you go on the plane, New Zealand, Australia, it will always speed up, and time and date confirms that, which is very interesting. I looked at the daylight hours from Ushuaia, and we get 17 hours daylight on our summer solstice on June the 21st, and Ushuaia on December 21st gets the exact same amount of daylight hours on their summer solstice, but on the opposite latitude. So that's quite interesting as well. This is me hard at work. I just made a little time lapse of me actually collating the data. This is a 2.5 hour time lapse, but this is just to show you that, you know what I mean, I didn't just take somebody else's numbers for granted. I actually worked out the meridian passing data myself. You see how I sit up with my back, because my back's aching that much, I'm like trying to stretch my back at the same time. Look, that's why I keep sitting up like that. It was quite funny. Well, there I'm gone. And I'm back. So more observations. So we've seen now that when the moon leaves the Tropic of Cancer and heads towards the equator, it speeds up in its cycle. Not only my observations show that, but it's backed up by that meridian passing on time and date, and it clearly shows that when the moon leaves the equator and heads towards the Tropic of Capricorn, it slows down in its cycle. What I just want to show you now is it's not a fluke either. If you look at these readings, every single one in yellow there is when the moon heads from the Tropic of Cancer to the equator. And what you'll notice, it always speeds up at that point. Look, 24 hours, 42 minutes, 24 hours, 42 minutes, 24 hours, 43 minutes, 24 hours, 42 minutes, 24 hours, 43 minutes, 24 hours, 42. At that point, every single time. And what I did, I created a graph. It looks like a heartbeat. And we all know that everything is electrical. If we die, touch wood, what do they use to bring us back to life? Electricity. Everything around us is electric. The sky's electric. Yeah, we generate magnetic fields, and so does the sky. And clearly that the moon is like a pulse. If you put it into a graph, it looks just like a pulse. So it just proves you that the moon, when it does speed up on the equator, it's not just a fluke. It happens regular, and that's over a full year. So more observations. So we've seen, I've just said this, but I'll say it again. We've seen the moon now that it speeds up when it leaves the Tropic of Cancer and heads towards the equator, but then it slows down. But what's the moon doing when it actually leaves the Tropic of Capricorn and heads back north to the Tropic of Cancer? Well, let's find out, because I've captured the moon coming back as well to complete the observations. So this time I waited till the moon was on and around the Tropic of Capricorn, as you can see there from my good friend Jose Silva. It's time lapse, and moon's below the celestial equator in what I call the southern circuit. Also, I just want to mention that everything I'm referring to in this presentation is celestial phenomena and not terrestrial. Yeah, there is a difference. Yeah, when I'm talking about poles, I'm not talking about geographical poles on a ball Earth. I'm talking about magnetic poles, like on a magnet. So I just wanted to make that pretty clear. I'm talking about celestial phenomena, which is measured in declination, and not terrestrial, which is measured in degrees. Now, this image is always blown me away, because the actual bright spot is the moon overexposed, and what it did, it created a lens glare reflection and created an image of the moon. So that light there can create that image of the moon. Now imagine that on an epic scale, with the atmosphere acting like that lens and not the camera itself. And that's when I come to the conclusion that the moon is basically a light in the sky, and it's some kind of projection. I'm not talking holographic images here. I'm talking like a natural projection. The light in the sky and the atmosphere acts as a giant lens, and it can create an image of the moon, which this image proves, because that doesn't look like the moon to me. How can that create that? It's an optical illusion. What we're seeing out in the sky is an optical illusion. The moon looks like it's probably about 10 miles away. It lights up the clouds locally around it. You know what I mean? If you look at the moon in the daytime, it's the actual image of the moon looks a bit fuzzy and not very clear, but at night time it always looks crisp and sharp, the image, you know what I mean? A bit like a rear projection screen telly. When you're watching in the daytime with the curtains open, you've got a rubbish picture, but you close the curtains and turn the light off and you've got a nice crisp picture. Same with the moon. I think David Weiss did some interesting experiments with the eclipse, where he showed a similar kind of projected light, and he basically cut that light out to make the eclipse. Might be worth having a little look at that video, what he made of last year, which was quite interesting, and I actually related to it to my research. And also that Steve Torrance and Mike Kavanagh come to a pretty similar conclusion in their electromagnetic Earth video, when they said that the orb of the sun is probably a type of projected image. I've come to the same conclusion, and I'm going to stick to my guns on that. So, the electromagnetic ether. We know that matter comes in three forms. You've got your solid, you've got your liquid, and you've also got gaseous as well. But there may be a fourth. Yeah, and that fourth element may be the electromagnetic ether, which is a luminiferous substance for the propagation of light. Basically, it carries all the heavenly bodies according to their frequencies, altitudes. And the ether is made up of two great vortices or magnetic fields. And you've got one in the north. There's a time lapse with the camera pointing at Polaris. And you've got one in the south, which actually the stars rotate in the complete opposite direction. And that's from my good friend Paul Kofo, who took the shot facing south from New Zealand. If you put them side by side, there you'll see in the north, the stars rotate in a counterclockwise or anti-clockwise motion, and in the south, they rotate in a clockwise motion. Some people try and say that's perspective. I said it's two magnetic fields, personally. And just like a magnetic field, you'll see you'll have your vortex motion going one way. On the opposite pole, you'll have your vortex field going the opposite direction. It always goes in the opposite direction. And as you can see there, the moon, when it gets southern declination, it will basically cross the celestial equator, pick up on the ethereal currents in the opposing vortex, and be circling the opposite direction in the southern vortex. And then it will get northern declination, pick up on the northern currents, and be circling in the opposite direction in what I call the northern circuit. If you take a time lapse from around the equator, now if you move that land away, what you would see two vortices separated by the celestial equator. One goes one direction in the north, and one goes the other direction in the south. This is just to try and give you a visualization of what I believe the moon's doing. So when the moon is in the northern circuit, it will appear to circle, and as it picks up on the ethereal currents in the southern vortex, it will circle in the opposite direction. I know that might sound crazy, but if you go onto moon calc and you go to 70 degrees, what you'll find out is the moon will circumpolar from that observation. It'll be visible for 24 hours. So the moon will spend 2 weeks in the northern circuit in a counterclockwise direction. Then it'll spend the next 2 weeks circling the southern vortex in a clockwise motion. So it's basically going in a figure of 8. And I actually named it the lunar lemur. That's my own word I invented for that. We've heard of the analemma. Well, I actually made one up for the moon, and I call it the lunar lemur. And there you can see a snapshot of the moon over a 27, 28 day period. It clearly makes that figure of 8 pattern. Interestingly, someone said to me, well, if the moon is on the southern circuit from your perspective, how the hell do you see it when you're in the north? But we have this thing called refraction. And what you'll see when a celestial object is perpendicular with the observer, you will get less refraction. But as the moon, from my perspective, gets southern declination, or from the south gets northern declination, what it will appear to do, it will refract. And as that moon gets further and further away in the south, it will actually project further and further into the north. So it will be visible in the north, and going through quite a few layers of atmosphere, you will get something called refraction. And that's why the image of the moon will project itself into the north from the south. And here's an interesting daytime shot I took of the moon. I took a time lapse in the daytime, and you can see that the moon clearly emits its own light. It's not reflecting sunlight, it's actually emitting its own light. What is the moon? There's been a lot of questions about the moon over the years. When you look at the moon in the sky, it looks like a rock in the sky. It sometimes looks like a sphere. It sometimes looks like a disc. It looks like it emits. It looks like it reflects. Sometimes it looks solid. Sometimes it looks transparent or translucent. It's been there for a millennia, and we still don't understand what the moon actually does or what it is. We know the word month is derived from the word moon, but still, we still don't know what the moon is. And I think the moon could probably sit there for another 1,000 years and we might never, ever, ever know what the moon is. But I know one thing it's not, and it's not that. That's supposed to be the Discover Epic satellite, which is 1 million miles from the globe Earth, if you want to believe that. And as you can see, that's supposed to be the backside of the moon. Rob Simon would probably say it is Photoshop because it has to be. But that is supposed to be a real image of the moon taken from the Discover Epic satellite 1 million miles out. And as I mentioned before, my goal is just to find a little piece of that puzzle. If I can maybe contribute one piece of that puzzle towards finding out where we actually live, I'll be happy, and hopefully I can wake a few people up on the way. But that's my goal, just to find one little piece of that puzzle. That's it. That's my presentation. I hope you enjoyed it.